Alright, so in this video, I'm going to solve the equation 16 to the power of x is equal to x to the power of 2. So to solve this, I'm going to first start by taking the power of 1 over 2x on both sides. So I get 16 to the power of x to the power of 1 over 2x is equal to x to the power of 2 to the power of 1 over 2x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So we can use this property for both of these terms. 16 to the power of x to the power of 1 over 2x is equal to 16 to the power of x times 1 over 2x. And x to the power of 2 to the power of 1 over 2x is equal to x to the power of 2 times 1 over 2x. Now, the x and x cancel out on my left-hand side because they multiply out. So I'm left with 16 to the power of 1/2 on my left-hand side. And for my right-hand side, the 2's cancel out. So I'm left with x to the power of 1 over x. Now, my goal is to turn the left side to be in the form some number to the power of 1 over that number, so we can make that number our solution. Well, right now, this means that 16 and 2 have to turn into the same number. So we need to rearrange this so that 16 and 2 are the same number. So to do that, (16) is the same thing as 4 squared. So I'm going to rewrite it as 4 squared. So I have 4 squared to the power of 1/2 is equal to x to the power of 1 over x. And now remember, these two multiply. 2 times 1/2 is just 1. So I'm left with 4 is equal to x to the power of 1 over x. Now 4 is the same thing as -2 squared. And 2, our exponent here, I can rewrite as 1 over -1/2. And I have this times -1. So I have 1 over -1/2 times -1. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this -1, I'm going to move to be an exponent of -2. So I get -2 to the power of -1 to the power of 1 over -1/2 is equal to x to the power of 1 over x. And -2 to the power of -1 is 1 over -2. So my solution here is -1/2. Alright, so in this video, I'm going to be teaching you guys how to solve the equation 1 to the power of x is equal to 2. Now, I know what you may be thinking. 1 to the power of any number is itself 1. So how can 1 to the power of a number equal 2? Well, there is a method to solving this. So first off, let's take the natural log, or ln, on both sides. So I'm going to do ln 1 to the power of x is equal to ln 2. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front, so I get x times ln 1 is equal to ln 2. Now, ln of 1 is equal to 0. So I get x times 0 is equal to ln 2, meaning 0 is equal to ln 2. However, ln 2 is equal to 0.693, so this is false. So this method does not work, the usual method of solving exponential equations. Now what I'm going to do is use an important formula known as Euler's formula. So this formula states that if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but let's walk through it. So what if theta is equal to 0? Then this means that I got e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. And cosine of 0 is equal to 1, and sine of 0 equal to 0. So I get theta is equal to 2k pi. Now, if this is true, then e to the power of I times 2k pi is equal to 1. So, because this statement is true, then doesn't this mean that our original equation was 1 to the power of x equals 2. And this is equal to 1. This number right here is equal to 1. So we can say that e to the power of I times 2k pi to the power of x is equal to 2. All I did was substitute in that for 1. Now, if we solve for this, we should get our variable x. So what I'm going to do is I'm going to do the same thing I did the first time. I'm going to take the ln, or natural log, on both sides. So now I get ln of e to the power of I times 2k pi to the power of x is equal to 2. Now, if I have something in the form ln a to the power of b, this is equal to b times ln a. So I can move x to the front, and this is going to equal x times ln e to the power of I times 2k pi, which is equal to 2. Sorry, ln of 2. Now from here, this is the same thing as I times 2k pi times x times ln e, because I can again use the natural logarithm formula and bring this to the front. And this is equal to ln of 2. And if you guys already know, ln of e is simply equal to 1. So now I get I times 2k pi times x is equal to ln of 2. Now if I divide both sides by I times 2k pi, these two cancel out, and I get x is equal to ln 2 over I times 2k pi. Now I'm going to multiply both sides by I over I, which is equal to 1. So now I get x is equal to ln 2 times I over I times 2k pi times I. And I times I is I squared, and I squared is equal to negative 1. So now I get x is equal to negative I times ln of 2 over 2k pi. So this is my answer to this equation.